Right, today, simplifying radical expressions. Your learning target is I can simplify square roots and I can multiply square roots together. So let's look at a few definitions here. First of all, radical expressions are contained in a square root, and the radicand is what's inside of it. And then we're going to also look at the product property of square roots, which is two different square roots can be multiplied together into one square root, or you could have two different numbers multiplied together on the same square root and then you could separate them. Before we really get started, let's look at our perfect square roots. Now our perfect square roots will be square root of 4, square root of 9, 16, 25, and so on, all the way down to square root of 100. Could go beyond that, of course. So using that idea, I'm going to be doing these or simplifying these square roots two different methods. First method is the perfect square method, and I'm going to look at the number 45, and of all these numbers over here, which one will go into 45 evenly, and hopefully you say 9. So we will have the square root of 9 on 1 times 5, and that can be broken down to 9 and square root of 5, like so, and the square root of 9 is 3 and square root of 5, like so. Or, if you would like, to do it the other method, the factor tree method, you just break it down to a factor tree and then partner them up, because the idea of square root is the same number times itself. So we could look at it as 5 and 9, and then 9 could be 3 and 3, and the number times itself is 3. And then we'd have 5 still in the square root. So same answer, different ways of doing it. Perfect square root, that goes into 56, is going to be 4 times 14. In other words, that's square root of 4 and square root of 14. And that's going to be 2 square root of 14. Or the other method, square root of 56 can be broken down to 2 and 28, which is 2 and 14, which is 2 and 7. And then we have a number times itself is 2 outside of the parentheses, and then we have a 2 left over and 7 left over, which is square root of 14. Same answer, different ways of doing it. On this one here, we're going to have the 4, and then we're going to look at the 50. Now 50 can be broken down to 25 and 2. Notice I'm breaking it apart already. So it's going to be 4 times square root of 25 is 5 square root of 2, which is 20 square root of 2. Or the other method, we can look at the square root of 50 and break it down to 2 and 25, which will be 5 and 5. And the square root, partnering the number times itself, we'll put a 5 in front with the 4, and then the square root of 2. And that's going to be 20 square root of 2. Again, same answer. And then this one here is 3. Now, a lot of people will say it's 9 and 12. However, there's still a 4 in that one. That would have to be broken down any further. So what I'm going to say is, if you look at 9 as a possibility, always try 36 if it's a bigger number. And in this case, 36 does go into 108 3 times. So it's going to be 3 times 6 square root of 3, which is 18 square root of 3. Other method, 3 square root of 108. You can break it down to 2 and 54, which is 2 and 27, which is 3 and 9, and then another 3 and 3. Partnering up the square roots of 2, square root will be 3. So it's going to be 3 times 2 times 3 with a square root of 3 still inside. 3 times 2 and 6 times 3 is 18 square root of 3. So again, same answer. Alright, on this side, we realize that the product property of square roots can combine two separate square roots and multiply them together. So 3 times 5, which is square root of 15. And since there's no perfect square roots that'll go into 15, we're going to leave that one as is. This one here, it's going to be 2 times 24, which will be square root of 48. Now that one can be broken down. I know 4 goes into it, but if 4 goes into it, try 16 and maybe even 36. And we'll find out that 16 does go in there 3 times, which is 4 square root of 3. The other method, using that square root of 48, you can break it down to 2 and 24, 2 and 12, 2 and 6, and 2 and 3. and square root says same number times itself. 2 and 2 is 4, square root of 3 left over. Last one here, we can multiply regular numbers together, so it's going to be 3 times 2, and then square root of 7 and square root of 14. So it's going to be 6 and the square root of 98. So what we're going to look at is what number times, which one of our perfect squares goes into 98, and we find out that it's 49 twice. So it's 6 times 7 square root of 2, which is 42 square root of 2. And if we wanted to look at this one, there's different ways of looking at it. I'm just going to keep it the regular way. 2 and 49, 7 and 7, you see those together, so it's going to be the number 6 in front times the partnered up, the square root, 7 square root of 2, which is 42 square root of 2, like so. Alright, I'm going to put the blue over here on this one. The square root of x squared is x to the first. The square root of x to the fourth is x squared. You'll notice that the even powers, square rooting it, will just take half of it, and so on. Now the other method would look at breaking this down to x times x, and it's under the square root, so they partner up and give me x as an answer. And this one would be square root of x times x times x, and you'd partner up 2 of them, and that means I have an x in common with an x inside. And this one would be 4 of them, and I'd partner up 2 of them, partner up 2 more, so I'd have x times x in front and nothing else. And this one would have 5 of them, partner up with 1 left over, so x squared and the square root of x to the first power. Now that brings us to the question, what do you do with, let's say, something like x to the 7th in the blue method? Well, that could be broken into 2 separate ones. It could be x to the 6th and x to the 1st. And x to the 6th we already know is half, and then square root of x, like so. So depending on which method you want to use. I'll try the blue one first. 40 can be broken down to 4 and 10. X to the 4th I know is a perfect square root. Y to the 3rd, I'm going to put 2 of them in one of them and 1 of them in the other, and then z. So this whole thing, this left one, is a perfect square. So square root of 4 is 2. Square root of a letter to the even power is half and half. And then this is going to just remain 10 y z underneath the square root. If I did it the other method, we would look at the 40 as 2 and 20, and then 2 and 10, and then 2 and 5. So we'd have a 2 in front, leave a little space, 10, and then looking at x to the 4th, that'd be 4 of them, so x squared on front. We'd have y to the 3rd, that puts 1 of them in front and 1 of them inside, and then z inside. So either method will work. There you go.